Hi, okay, welcome to session 4. We're going to be using vectors to translate shapes today. So obviously we've got our recap first. Please have a good old go at that and then press play when you're ready to see the answers. Okay, so there's your answers. Obviously hit pause, mark. If everything's gone great, really, really well done. Questions 4, 6 and 8 are kind of the ones I think that may have posed a problem. So I'm going to go through those ones in a little more detail. If you don't need that, obviously get yourself into the new part of learning. If it did go wrong on any of those three, then this recap hopefully will be really, really useful to you. So let's make some space to work in. So question 4, you may be wondering where the A went. The A is no longer there. So let's just concentrate on that A term so that we can explain that rather than do the whole thing. So I've got A to the 7 times A to the minus 3. That's along the top with A to the 4 on the bottom. The power rule is to add, and 7 plus minus 3 will be 7 minus 3. So I've got A to the power of 4 over A to the power of 4. The rule, as we know, is take 4 will create A to the power of 0. And we know that anything raised to the power of 0 is equal to 1. So the number 1 could slot where the A is. So we've got the answer 3 for the numbers. Squash that, or I'm going to show it as a time sign, so hopefully it makes a bit more sense. What we got for A, which was 1, what we got for B, which was 6, and you see that that all tidies up to the 3B6. Okay, anything multiplied by 1 just leaves it as it is. So it just kind of disappears. The E's and the F's. Now you could have either collected those into their indice form. So you could have had E to the 2 times F to the 3, or not even shown that time sign. And then you could have taken it from there. Or, and I really like this, if you've got a times and a divide, it cancels out. So if we've got a times F divided by an F, it's cancelled out. It's cancelled out. It's cancelled out. And then you can see that your EF is left. And finally, your last one. This means 5 times x to the 0. Anything to the 0 is 1. So basically what was happening in question 4 is happening again here. And we end up with just the 5 left. So hopefully that has helped if anybody was struggling a little bit on that. Okay, translating shapes. So we know about vectors, we know how they work. We're being told to translate the vector, translate the shape, sorry, in the vector 4 minus 4. So this is what this looks like. Here we go. 4 forward, 1, 2, 3, 4. 4 down, 1, 2, 3, 4. And then you draw in your shape, which is 3 and then 5 down. Hopefully that's 5. And there it is, your new shape. However, what I've done is the most common mistake people make, to demonstrate it and show you that that isn't actually quite right. I counted 4 forward, I went 4 down, I didn't do anything wrong with the vector. But if you think about that corner that I counted from, that corner is over there. That is definitely, let's draw it in so you can see, that is not the vector 4 minus 4. So when you count from a corner, it's really, really important that you draw from that corner. So let's correct this. And I'm going to just put the shape on top and I'm going to move it 1, 2, 3, 4, and then down 1, 2, 3, 4. And now my green dot is in the right position for that 4 minus 4 vector. And what I've just demonstrated with the kind of moving of the actual shape itself is something that you could do in your GCSE because you are given tracing paper. Tracing paper is considered a tool. It is given to you in your exam. And the reason that you have it is for these types of questions. So what you could do if you are someone that gets a little bit muddled by shape work is just trace it out and then count by moving the tracing paper, and it shows you exactly where to draw it if you do it like that. You could just count and put in your vector line if you wanted to. I don't bother with that. I think you end up with too many lines and it gets a bit more confusing. So I literally just do my dot count and leave it at that. All right, let's do one to have a go at. There we go. So we will do this shape here, nice and simple. And we're going to do that, please, in the vector -2, -5. So I'd like you to draw that one out, have a go, and then hit play when you are ready. Okay, here we go. So we're going 1, 2, and then 1, 2, 3, 4, 5. I have counted from that corner, and I am going to make a big deal about highlighting that so I do not make a mistake when it comes to drawing. So I've got to go back 3, down 2, and join it up. And if you got that in the right place, really, really well done. We'll do one more before we go on and see where else this topic can go. So don't want to draw anything too complicated because my software can be very stubborn sometimes. There it is, perfect. All right, we are going to go, let's go 4-2. There you go, 4-2. So have a go and then press play when you're ready. Okay, so I am counting from this corner. 1, 2, 3, 4, and then up 2. So I am going to go 2 back, 4 down, round, and there is my new shape, 4-2. And if you got that right again, well done. All right, next thing that we're going to look at is this type of question here. It says, describe the single transformation that maps A to B. So the first thing that I want us to do is just take in that word. It's a really important word. It's going to come up in your exam. And I call it like an umbrella word, or like imagine a family tree and you're the person at the head of the tree and everything kind of comes off it. Transformation is the topic that translation sits in. So there are 4 areas that can be described as transformations. Translation, which obviously we're doing now, reflection, rotation, and enlargement. And all 4 of those transform a shape from one position to another. The enlargement actually changes its size as well. But they all transform it from, like I say, one position to another. A reflection will flip it, a rotation will twist it. Our translations are sliding the shape around, but they're always staying congruent. Apart from enlargements, where the shape changes in size, the rest of the transformation are congruent shapes, which means they are absolutely identical in every way. Angles and edges are all equal between the 2 shapes. So congruent is another really important word that fits in with our transformation topic. All right, so we've got to describe the single transformation. One of the reasons that they use the word single there is because if you were in a little bit of doubt, you might go, oh God, I can't remember. Is it a translation or a reflection? Oh, I can't remember. You write them both down. Okay, translation is correct, but because you've written reflection, you've kind of shown you didn't really know, so they're not going to give you the mark. They will literally take it away from you. So you really must only write one transformation. So what we're going to do is we're just going to choose a corner that's the same on each of the shapes. We are going to draw in our vector to those corners. So there's my vector. I like putting the line on for these types of questions, just in case my count goes wrong. It kind of helps guide my count, but the count is still essential at the end of the day. So you could argue that that line isn't necessary, and it's your learning, so you decide what you're going to do. So I've got to go 1, 2, 3, 4, 5. I've got to go 6 forward. So I've got 6 in the top of my vector, and then I'm going 1, 2, 3, 4, 5 up. So the way that I will describe this is I will say it's a translation in vector 6, 5. And that will get me the 2 marks that goes with that question. Okay, so have a look at this question. And when you've written down what you think is the right thing, press play. Okay, so we're going A to B. So there's A to B. I'm going to draw in my vector. And I can see that I've got to count 1, 2 forward and 1 down. So a full sentence to get me my marks is to say translation. It's exactly the same sentence. Translation in vector 2 minus 1. Okay, I'll just bring that one down so you can see it. Have a go at that one for me and hit play when you're ready. Okay, so I am going to choose this corner to this one here. And I'm going to put my vector on. All being well, it will do it nicely for me, all the way up to the top there. So that's a really good example of how it would be so easy to just stop at that bottom corner. It almost feels natural to do that. So having that highlighted on really stopped me making that mistake. Okay, now when I go to count, there's obviously no need for me to move in any direction this way. So the top of that vector is going to be 0 because I don't want to move forward or backwards. And then I'm going up 1, 2, 3, 4, 5, and 5 it will be positive. So this is translation in vector 0, 5. Okay. And that's the topic, basically. You're either going to be asked to draw it yourself, move it, or you're going to be asked to describe it. And I always see this as it's like someone's rubbed out the original question. So if that B hadn't already been drawn, you would have been asked to translate it in the vector, da, 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 da. So it's just like someone's rubbed out that initial question and someone's just got on and done it anyway. Okay, so we have some for you to practice. This is available to you to print so that you can just work directly on it. I do have this squared paper, blank squared paper for you to print at any point if you want to be working on squared paper for any lesson that we might do. I am going to scroll through this slowly at this size so that anybody who is working from the screen is able to see it clearly. And then they can just pause and play when they want. I'll do the same for the answers. And then I will see you next session. So well done today.